Okay, so following on, so just to remind us, what we've got to do is calculate the perimeter of special shapes. So what we mean by special shapes is really to do with the circle. So the perimeter is the distance around the outside of the shape. So when it's nice and easy, like straight lines, you just add up all the sides. Right? So even if it was sort of an L shape or something, you just add up all the sides. So for instance, if I've got a rectangle, if it was a 3 centimetre by 5 centimetre rectangle, it would be what? That would be the area, 3 times 5.
16.
So the area
16.
is 3 times 5, but the perimeter is, well, 5, so this would also be 3.
5 is 10. 3
Exactly,
plus
5 plus 5 is 10, 3 plus 3, so the perimeter would be 16. What are the units of?
Centimeters square. Centimeters.
Just centimetres, because it's just the length, you're just adding up 4 lengths. Okay, what would the units of area be again?
Centimeters square.
Centimetres squared. Okay, now this triangle, right, just to check, if I put those 3 lines and then I put a 7 millimetres, I'll make it a really small one, okay, what would the perimeter of this triangle be?
21.
21 what?
Millimeters.
Millimetres. Okay. The parallelogram, basically the same as a rectangle. So if it was 5, 4.5
18.
centimetres,
19.
so the perimeter would be,
19
so this would also
centimeters.
be 4.5, this would be 5. So yeah, it'd be 5 plus 5 plus 4.5 plus 4.5 makes 19, and the unit? Centimetres. Okay, right. So that's an easier one. Just to add one little thing we didn't draw
Do
yesterday.
we write the answers of the parameters or not?
We will do in a second, not just yet. So if I were to draw another shape though, right, like this. So this is where we potentially have to think a little bit more sometimes. You'll be able to draw this in a second. So you can see what I'm doing. So imagine I've got to draw this every time. That's what you would have to do for the perimeter is thing. Well, what are the lengths of every side that I've just drawn? So for instance, if I told you that was 8 centimetres, this was 3 centimetres, this was 7 centimetres, okay? This was 5 centimetres, right? What would the perimeter of a shape like this be?
23.
23. Why do you say that?
23.
But what's your,
Oh no, you didn't do all of the sides.
Only split the shape in between.
So you want to split it? Do
No,
we
no,
need
no,
to do that? Because
diagonal.
we do that with area, don't we? We have to split it with area. But when we're doing perimeter, do you remember the perimeter is just all the sides added up?
But you don't have all the sides.
We don't have all the sides, no. So we have 8, we have that side, we have that side, we have that side, we have that side, and what are we missing?
That one.
This one and this one. Okay? So that's where people can make a mistake.
But will
so-
there always be all of the sides, or are we always going to have to find out?
But you might have to find,
But how
normally,
we're gonna have to-
okay, so there's the question.
Oh, it will give us a finished perimeter, and then we're going to have to find the rest.
You could do, yeah, that would definitely be one way of doing it. But, for instance, in this question, you could find those 2 missing links.
Oh,
and-
5?
Why
It's a
5?
right angle, so they need to be what? No,
No,
because
the right angle doesn't mean they have to be the same length.
The one down would be 2.
The one down would be, here would be 2, you think? Why?
it's a little bit smaller than the 3 centimeters one.
We can't, I should maybe write here,
It's longer than the 5 centimeters.
not to scale, Therefore, you can't look at the diagram and take anything from it.
How are we supposed to find it out then? If there's
Well,
no
because
numbers?
this length here is the same as this length here. Alright, so if I draw that line in there, now I know that the whole thing is 8. This length here is 5.
Oh, 3.
So this bit has to be 3.
But it doesn't look equal to the other 2 centimeters.
It doesn't have to.
Oh.
Not to scale, remember?
Oh, okay.
It doesn't have to look the same. So the same way, this one here, so all of that distance should be 7. Therefore, this little bit must be
4.
4. So that's that length now.
Ooh.
Okay, so that's how you use what's already there. So the perimeter would now be 3 plus 5, 4, 3, 7, and 8. So I've got 1, 2, 3,
30.
4, 5, 6. So just check 6 numbers, yeah.
30.
30, just check. 5, 8, plus 4 is 12.
13.
Plus 3 is 15. That's another 15. So yeah, 30 centimetres. Okay? So that's how you would find if it's sort of a compound shape like that. Alright? I do want to go into the circle bit, but I think that will be quite complex. So do you want to write those ones down first? So, what we're looking at, so we've got the other shapes. Perimeter is a lot easier than area. Okay? So area takes a bit more thought. So area of a rectangle is fine. We didn't do triangle, parallelogram. We've done them before. Area of a circle. Now, do you remember how to work out the area of a circle?
Yes.
You do, okay? What is it? What's the formula for the area of a circle?
It's the pi.
Something square.
Pi times something squared. What's the something? You're right, it's pi. Do you remember what pi is, by the way?
Yeah, any number.
No.
3.14.
3.14, well done, Joanna. It's 3.14 is pi. Goes on forever though, doesn't it? But 3.14. And what was it? It was times r squared, yeah? So if you can't make that out in your notes, maybe change it. What is r? Radius. So from the centre to the outside of the circle is r. Now that's the area of the circle. So what about the area of the semicircle? Exactly, yeah. So pi r squared divided by 2. Right? So we remember that. Now here's the thing. If we're doing perimeter, we were just talking about it, to walk around the edge of a shape that's all straight sides, you just get your ruler out and you measure how far you go. Fine. If we were going to do it in real life. But how do we do it with a circle? Now, here's the thing. Do you ride bikes? So a wheel is a big circle, yeah? Have you ever ridden a bike through a puddle?
Yeah.
And then have you looked what happens after you've come out of the puddle?
Yeah.
What happens?
The tracks of water.
But afterwards. So the water splashes everywhere, but what happens?
Your wheel leaves behind a track.
The wheel leaves behind a track. Does that give you any clue as to what you might do?
Yes!
You like open up.
Yeah, so what we have this idea, whereas, you know, if I've just got a piece of paper, take this piece of paper, flat, straight piece of paper, if I roll it up, what shape do I get?
A circle.
So at the end it's a circle. So really, when I want to work out the perimeter of a circle, I need to work out that length. So what I could think of it doing is laying it flat and then measuring that length, yeah? Now, to do that with something that you can't roll out, imagine, well, have you ever used in science one of those roller wheel thingies that measures distance? So yeah, it's on a handle, and you start it and it rolls and it clicks.
No.
You never had one of those. We should have got one. You've
bought
seen
it
one,
at
and you
Disneyland.
walk it and it goes click, and you go 1 meter.
No.
Or click,
No,
2
not
meters, roll. click 3 metres and so on. And that's because the wheel we know is 1 metre round. Now, how do we figure out if we get given a circle? Now, one way to do it, if you've got a bike, for instance, what you can do is put a bit of, I guess, water on one bit of the tyre. It hits the ground, it makes a wet mark. You roll the wheel along, and when the wet mark gets made again, you measure that straight line. That's how long the wheel goes.
But obviously we can't actually have a bike in the actual test, so...
No, well, I'm just explaining how we get there.
Yeah, but...
So another way that people did it when they wanted to measure circles was they got a circle and they laid a piece of string around the circle. So have
and measured
string.
the piece of string.
And they measured the piece of string. So for instance, here we go. Piece of string. Alright. Have you got compass? Or do I need to lend you? I'll lend you a compass. Alright. Now, what you're going to do is draw yourself.
Oh, there's a circle there.
Yeah, but let's draw draw one. So we're going to draw a circle. You're going to use your string to measure how big the circle is. So when you measured around your circle with string, what we then did was we took the perimeter and we divided it by the diameter of the circle, and you got an answer. It's slightly different. Now, here's the thing. You girls basically got what? Answer? The same. 3. Yeah? You get that? You got 3.2, you got 2.9. But actually what I know from that is that you've both done that pretty well. Okay? Your measuring around the circle is pretty good. Because what they found out is that when we have perimeter divided by diameter, any idea what number they always got?
3.
Not 3 quite, but
3 points, something.
What do you reckon?
3.14.
Pi. So you got quite close to 3.1. So what? Obviously, as things got better and better, more accurate, there's another way of finding pi. So actually, what we found by doing that, this is what you do need to remember. So obviously, in a test, you don't need the string, but you do need to know that the perimeter of a circle is found by doing pi times the diameter.
The circumference.
Okay, now the perimeter of a circle has another name, which is circumference.
But still, how would we actually measure it?
So for instance, well, you're not actually going to measure, are you? So
no, but like in a test, I might ask, what is the perimeter of it? But obviously, if we don't, we need like something to measure the outside.
No, you don't need something to measure, do you? What you do need is, right, I don't know why I did that. What you do need, however, so if we have a circle, as an example, right? If I tell you that this circle has a diameter of 5 centimetres, what we should be able to do now is say that the area is pi times, well, we need the radius, so the radius is, well done, 2.5, so it's 2.5 squared.
So where did you get 2.5?
Because it's half of 5.
Oh.
The radius is half the diameter. If you remember that.
Yeah.
Good. And the circumference, or the perimeter, okay, would be pi times
diameter,
which is 5. Now pi is just a number. So on your calculators now, what you're going to do, you can do 3.14 times 5, and you can do 3.14 times 2.5 squared, or times 2.5 again. So can I get you to work out the area and perimeter of that circle for me? Do that on your calculator. What do you get?
15.7.
For which one? The area or the circumference?
3.14 times 5.
Okay. So the circumference we think is, what did you say?
15.7.
15.7 centimetres. What do you think the area is? Have you worked that out?
Wait, how would you find the area?
So 3.14 times 2.5 squared. So 2.5 times 2.5.
19.625.
19.625
And what's the units?
centimeters cubed.
Squared. Okay? So that's how you find it. That's how you find the circumference and area of a
So
circle.
you would always give us the.
Yeah, so I'd have to tell you what the size of the circle was. Yeah. Do you want to write that down? We haven't done semicircle yet. I'm going to ask you about that in a bit.
Half. That would be half. If the circle's the
Got to
same
be
shape.
careful.
If
Got
the
to be
circle's
careful.
the same shape.
I'm going to ask you, can you work out another one for me? So you're going to write down your notes, but I'm also going to ask you for the area and circumference, so perimeter, of this one for me, please. Alright, so circle 4 centimetres. So write that down like we did and then work out this next one for me, please, in your book. Okay? So if we're doing area as pi times the radius, it's kind of set up nicely for it. So it's pi times what? Jana, you got that? Pi times for the area. Pi times which is for this problem. What's the radius? 4. So we've got pi times 4 squared, which is what? What's 4 squared, by the way? So it's 3.14 times, what's 4 squared? 16. So if we work that answer out, go on, Jonah, what is the diameter then? So to work out the circumference, it's pi times 8. Good. So we've got 3.14 times 8. So what are those answers using your calculator? So 3.14 times 16. Are you with us, Sophie?
No.
No. Which bit are you lost at?
I don't understand if we're supposed to find the perimeter or the area.
Both. That's what we're doing. We're doing both of them. So first of all, I found the area, which is the space taken up. So it's pi times the radius squared. So I've done pi times 4 squared. So that will give me the area, which is, Jane has just worked out, is 50.24 centimetres squared. So that's the area. Now the perimeter, also known as the circumference, is found by doing pi times the diameter this time. So it's pi times 8 because the diameter is all the way across.
Yeah.
So if half of it is 4, the other half is also 4, so it's 8 in total. So pi times 8 is 3.14 times 8 is 25.12. And the unit? Centimetres. Good. Okay. Okay, so semicircle makes sense that it's half a circle. So we've got the same circle, but I've only got half of it. So if I take the area of the full circle and divide it by 2, I get the area of the semicircle. However, what about the circumference of, or the perimeter of this semicircle? What would the perimeter be of the semicircle? What would you say? Is it 25.12 divided by 2? No? Why not? If it's half the circle, surely it's half the perimeter as well. Half the area, makes sense, yeah? What about half the perimeter? Does that make sense? Or do you think there's something wrong? Right, girls, I'm going to ask you to have a think about this, because obviously we're going. I want you to have a think for the next time I see you. What do you think the perimeter of this semicircle will be? You've got it? Think it through, think very carefully. I want to know the perimeter of that shape. The perimeter. What I'm doing with my pen might help you think about it. See whether you can come up with what you think it would be next time. Okay?